All right, so our new topic is sequences and series. Now, as always, let's go through the pain of defining things. The first definition that we want to do is sequence. Okay, so sequence, everything we deal with when it comes to sequences and series has to begin with a sequence. Okay, so a sequence is an arrangement of numbers. So it could be 1, 2, 3, 4, 5, like that. That's an arrangement of numbers. Okay. Now, in us going deeper to check the relationships between these numbers, how are they growing from going forward? We then can discover that they can either be an arithmetic progression or they can be a geometric progression. So this one we call GP and this one we call AP. So an arithmetic progression will have a common difference, what they call a common difference. Okay, so you'll see that maybe between here we have 3, between there we have 3, between there we have 3. And so we can determine the proceeding values. So we can bring the same 3 here and know that the next one here is going to be 13, if I've done it right. Okay, something like that, right? Now, when it comes to the geometric progression, you will see that the difference is not common. And remember, this D. So when we're working with arithmetic progressions, we have 3 important letters or elements. The first is the number of terms, the second is the first term, and then the difference. So once we have this, we can discover the arrangement if we're not given the full arrangement, or we can actually get the next term and all that. Okay, then now here we have a geometric progression. So what do we do with a geometric progression? We can check that here you see the difference will not work anymore. Here we have the difference. If we use the difference, let's say the difference is here on top. Here we find it's 4, there it's 5, there is something else like 18. Okay, you can see that there is no commonality between these. So we can't use this to tell a story. Okay, but if we came here and maybe found the ratio between these two, we find that if we divided the first into the second, we find it's 3. This into that, we find it's 3. This into that, we find it's 3. Then we know that if we came here and either multiplied this or divided into the next number, there should be a relationship between these two numbers. So you can see here I can multiply, I get 3. Here I multiply, I get 9. Here I can multiply, I get 81. Right? So this now we'll call a ratio. So you see that the geometric progression is going to deal with 3 different things as well. And these are going to be the first term, we're going to have the number of terms, and then we're going to have a ratio. So that's the difference. So you see arithmetic progression has got n, this one has got n. They've both got a1, which is the first term, and the main difference is on the factor here, the growth factor. Is it going to be a difference? Is it going to be a ratio? That's the main difference. So now we've defined these two. Okay, what about series? What is a series? So a series is defined as a series is normally defined as a sum of the elements in a sequence. Okay, so the elements here, you add them together, you get a series. And you see that the sum now, which they normally call Sn, will also be based on A1, N, and difference. So these are the only letters, the only elements that we have to deal with. The sum here is also going to be Sn, A1, N, and then difference, ratio. Okay. So these are the definitions, and this is the theory for sequences and series. In the next video, we're going to derive the formulas for sequences and series.